Hello, my dear students. Welcome to mathematics classes for 9th standard. We are doing chapter number 10, that is circles, and this is part 2 of circles because in part first already we have learned about the basic things of the circles and we have done exercise 10.1. Today we are going to move forward towards the theorems which are given in the exercise in this book NCERT. Okay, so we are going to learn 10.1, 10.2 and 10.3 and 10.4 theorem, and we are going to solve exercise 10.2 also. So let's solve this exercise and let's learn about the theorems given for the circle by your Jerry sir. So students, in our previous video we have learned about the basic things of circles and we have done exercise 10.1 of NCERT. Today we are moving forward and we'll learn some theorems based on circles. So first theorem 10.1, which says that equal chords of a circle subtend equal angles at the center. Now if we talk about chords, so as you can see here, AB and CD are the two chords and they are saying that according to this theorem these two chords are equal. So chord AB is equals to chord CD. It is already given in the question. AB and CD, these two chords are equal. So according to this theorem, if two chords of a same circle are equal, then the angles which made by these two chords at the center, or we can say the angle subtended by these two chords at the center, will also be equal. So see, chord AB is equals to chord CD, therefore angle AOB, this angle will be equal to this angle, and these both angles are made by these two chords AB, so made this angle AOB, and then CD is also a chord, so which angle is made by CD? This angle COD. So angle AOB will be equals to angle COD. This is the theorem 10.1. Okay, now theorem 10.2, which is the converse of 10.1 only. Here we are given that equal chords are given, then the angles subtended by them at the center will be equal. Now we are given that if the angles subtended by the chords of a circle at the centers are equal, then the chords will be equal. Now see, just pay attention, this is the converse of theorem 10.1. Now this time we are given these angles are equal, which is made by the chord at the center. It means AOB is equals to COD. It is already given. See. So according to this theorem, if the angles which are subtended by the chords at the centers are equal, then the given chords will be equal. See, AB is equal to CD. If angles are equal at the center, then the chords will be equal according to 10.2. And 10.1 says that if chords are equal, then the angles subtended by them at the center will be equal. These are the theorem 10.1 and 10.2. Now on the basis of these two theorems, we are going to solve the exercise 10.2 of exercise of NCERT book. Let's solve. So this is exercise 10.2. Recall that two circles are congruent. Now they are using the word congruent. Congruent means it means equal in shape and equal in size. It means two circles are given which are of equal, or you can say same size and same shape. It means they are of equal radius. They are of equal radius. Then only they will be called like congruent. No, see, if they are having the same radius, that's why they are what? Congruent. So prove that the equal chords of congruent circles subtend equal angles at the center. It means that it is the same theorem which we have just read out. So that theorem only we have to prove. That's why I have not proved that theorem that time. Now I will prove that theorem with the help of this question. So let's see. Questions I have written there in this short form. 10.2 exercise NCERT question. What is congruent circles? Two circles which are in equal shape and equal size, or in simple form we can say that two circles will be called congruent if they are having equal radius. So we can say that we have made two circles. As you can see, they are of same shape and same size because these both angles I have made of equal radius, that is 2 cm. If you will measure this OA and OB, this is 2 cm. Even this OC and OD also 2 cm. That's why these two circles are congruent. These two circles are congruent to each other. Now see, in the according to given question, it is given that the two circles are congruent. Circle which is radius is O, which center is O and radius is R, and the circle which radius is O dash and the radius is R. These two circles are congruent with equal chords. Equal chords are also given. It means AB is equals to CD. It is also given in the question. Now what we need to prove here? We need to prove the theorem only, that equal chords of congruent circles subtend equal angle at the center. Two chords are given which are equal, therefore these angles should be also equal. This thing we have to prove. Now let's prove it. So in triangle AOB and triangle CO'D, this is O dash, okay, CO'D, we can see that OA is equals to OC. OA is equals to OC. Why? Because these two triangles are congruent, therefore their radius will be equal. So radii of congruent circles. Then radius OB. OB is also radius. Just see center to the any point joining the line segment is joining the center to the any point on the circle. That is called radius. So OB is also radius and OD is also radius. So OB equals to OD. OB equals to O dash D. This is again same reason, radii of congruent circles. And at last AB is equals to CD because it is already given in the question in the starting only. So we have proved three things. Therefore we can say that triangle AOB is congruent to triangle CO'D. So we have proved that these two triangles are congruent. Once we have proved that these two triangles are congruent, so easily we can say that angle AOB is equals to angle CO'D by CPCT. And how we have proved that these two triangles are congruent? By triple S congruence rule. Okay, side, side, side. So we can say that these two angles are equal. Angle AOB equals to angle AOB equals to angle CO'D. And this thing only we have to prove. Okay, we need to prove this thing only. See, equal chords of a congruent circle subtend equal angle at the center. So we have proved that the angles which are made by these two chords, equal chords at the centers, are equal. So here we have proved our theorem, or we can see this question also. In the same way you can solve the second question. Just check second question. Prove that if the chords of congruent circles subtend equal angles at the center, then the chords are equal. This is the converse of this theorem. So easily we can say. Now this time what is given? Chords of congruent circles subtend equal angles at the center. It means this time they are saying that the angles are equal. Okay, and you have to prove that these chords are equal. You have to prove this one. Converse. So we can say again OA equals to O dash C, OB equals to O dash D. Okay, and what we can say, angle AOB equals to angle CO dash D. If then by side, side and angle, it means SAS, we can say that these two triangles are congruent. Therefore AB is equals to CD. In this way we can prove the second question. So you can try second question by yourself. Now move forward to other theorems. So now we are moving towards theorem 10.3, which is perpendicular from the center to a chord. We are going to learn about this perpendicular from the center to a chord. So what this theorem says, just read it. The perpendicular from the center of a circle to a chord bisect the chord. Bisect means dividing into two equal parts. As you can see here, we are given a circle, as you can see. Okay, and according to the theorem, they have given that a chord xy, we have assumed that the chord name is xy, okay, of a circle which radius is r and center is o, and here OZ is perpendicular on xy. What I am saying, OZ is perpendicular on xy. Perpendicular means they will make 90-degree angle both sides. Here also 90-degree angle and here also 90-degree angle. Okay, now what we need to prove that? We need to prove that it bisect the chord, the line which is coming downside, no, perpendicular line. It means OZ, perpendicular. It bisect this line xy. It means here zx equals to zy. This should be equal. Zx should be equal to zy. This thing we have to prove. Okay, so we are doing just little construction. What we are doing, we are just joining this O to x and we joining this O and y. OX and OY we are joining. So what we form, what we get? We get a triangle OXY. Now in this right triangle OZX and OZY, we got two triangles OZX and OZY. We can see that OX is equals to OY because they are the radius of a circle. Okay, OX and OY, they are the radius of same circle. In the same way we can say OZ equals to OZ because OZ is coming in this triangle also. OZX and OZ is coming in triangle OZY also. Okay, so OX radius equals to radius OY. Then OZ equals to OZ common, and angle OZX equals to OZY because these both are 90-degree angles. So we can say by RHS, right angle hypotenuse side congruence rule, these two triangles are congruent to each other, and if the triangles are congruent, then easily we can say ZX or you can say XZ, whatever you want. Okay, zx equals to zy, and this thing only we need to prove. So we have proved that zx equals to zy by CP/CT. Now there is a converse of this theorem in theorem 10.4. Converse of the same theorem. The line drawn through the center of a circle, the line which is coming from the center, like this line is coming from the center to a circle, bisect a chord. Now here they are saying it bisecting the chord already. It means they are saying that here already they are given that zx equals to zy, already they are giving. So what we need to prove? Then is perpendicular to the chord. Now we need to prove that these angles are 90 degree. Okay, in this theorem 10.4. This is the converse of above theorem. In above theorem we are given what? We are given that a chord xy is there in which perpendicular is coming OZ on xy. It means this 90 degree angle already given. Just we need to prove that this perpendicular bisecting this chord, it means zx equal to zy. I think we need to prove this thing. But in theorem 10.4 they have already given that zx equal to already zy. It means this line already bisecting this chord, but these two angles should be 90 degree angle. It means this OZ should be perpendicular on xy. This thing we need to prove here. So given what? Xz equals to yz, xz, or you can say zx equals to yz, or you can say zy, and we need to prove what? OZ is perpendicular to xy. OZ is perpendicular on xy. It means we need to prove this. These both angles are what? 90 degree angles. So students, just to try to solve this question, just I am giving you hint. Again, what you can do? Again you can take these right triangles OZX and OZY. You can say OX equals to OY. Both are the radius. Then you can say what? OZ equals to OZ common. And last thing, what you can say, that XZ equals to ZY, because this thing is already given here. See, XZ equals to YZ, है So by you can say side and side, by triple S, these two triangles are congruent. If these two triangles are congruent, so we can say that angle OZY equals to angle OZX, angle OZX equals to ZY by CPCT. Okay. Now what we need to prove? We need to prove that these two triangles are 90 degree angle. These two angles. So we can prove. Now see, OZX and OZY, what they are making? Linear pair. What they are making? Linear pair. It means angle OZX plus angle OZY equals to what? OZY equals to 180 degree linear pair. Okay, you can write. Then we just prove that these two angles are equal. So in place of one angle, what we can write? OZX. Okay, leave it OZX. In place of OZY, again I can write OZX only, because these two angles are already equal. 180. So how many OZX? Two angle OZX. 180. So what will happen? These two will go downside. So angle OZX equals to 180 divided by 2. It means 90 degree angle. So it means OZX equals to how much? 90 degree. If angle OZX equals to 90 degree, therefore OZY is also 90 degree. In this way we can prove this converse of this 10.3 theorem, that is 10.4 theorem. Okay, I hope it is clear. So on the basis of these theorems, now 10.1, 10.2, 10.3, 10.4, we can solve the coming questions. Okay, now just very important thing I need to tell you, just check your NCERT book. If you move forward, so you will find after 10.4 you will find theorem 10.5. This year, this theorem, there is one and only one circle passing through the three given non-collinear points. This theorem is deleted by or removed by CBSE. So this theorem is not coming in your exams this time. Okay, and the exercise 10.3 is fully removed. Okay, this 1, 2, 3 all are removed by CBSE this year. So exercise 10.3 is not coming in your chapter circle, or this theorem 10.5 also not coming. Okay, so next time we'll move to other theorems and then we'll solve exercise 10.4. okay, I hope it is clear to you. Thank you, students.
At last, I just want to say be safe and God bless you all.